Hi, I'm Ben Wycliffe. In this video I'm going to be talking about a paper titled Multiple Linear Regression Model for Improved Project Cost Forecasting. It's a paper review. So this paper is tackling the idea of estimating eventual project costs, and this is something that is crucial for determining the success of a project. So one way that is known to be that is popular, usually utilized to forecast the project cost, is called the value management methodology, and it's used to represent the solution based on these features, which include the planned value, the earned cost, and the actual cost. So it is sort of implemented on top of a traditional statistical approach, and with this they are able to obtain the objective estimate of future costs, but this is with the assumption that there are no further interventions on top of these data points. So the problem here is that the statistical formulas used in the computation of EVM, much as they're easy, they show some sort of inefficiencies, as they only account for the actual work situation, and then they assume linearity of the project labor profile, which is unrealistic in the real world. And then they also lead to the neglection of index trends over time, because things keep changing. So the assumption that no further shifts in performance or risk will occur is not a valid one. So with this, they proposed an approach that works with an EVM dataset that is related to 29 different real-world projects. So with this dataset, they didn't have to do any sort of data cleaning, and these were the features that appeared in the dataset. So these included the normalized time period, the percentage of work scheduled, the percentage of work performed, the actual costs, the scheduled performance indexes, and the cost performance indexes. So on top of these features, they also include the function of the estimate at completion, which we talked about initially, the statistical model that's typically used. So they include this as a feature as well. So in this formula, you see it uses some of these features to make the estimate. So here in this BSC is the budget at completion. So yeah, the idea is that this is also a feature added on top of this. So the methods, of course, they employed multiple linear regression, and the reason behind this was they were trying to come up with, they were trying to avoid the more complicated or sophisticated approaches. They wanted to come up with something really simple. So they went ahead and generalized the linear model selection and initial input diagnostics. So they sort of were evaluating the impact of the different variables that appear in the dataset, and then they proceeded with assessment of correlations between their variables. So they use absolute shrinkage, or sort of like dimensionality reduction approach, along with the lasso regression as a sort of like a regularization method, and k-fold cross validation. So a combination of these is what they use to address the issues of overfitting. And then they proceed with a correlation analysis, and then finally conclude with a multiple linear regression analysis for their features. So in terms of some of the outputs they have, this is the regression analysis. So after after doing the model selection and the correlation analysis. This is the correlation matrix they generated. So you can see from this that some of the features are highly correlating, like WS and WP and AC. They have a very high in correlation score, so they're almost similar. So at this point, they had to do away with two of these and retain one. So they retained the WP feature for their modeling. So this was the resulting linear regression model. So you see their model has three regressors, including the ESC, the CPI, and the WP. So the CPI is the cost performance index, and then ESC is the estimate at completion. Again, we talked about this. This is a feature generated through the EVM methodology, and then the WP is the percentage of work performed. So with this, they get this performance with their model. So in comparison with the statistical model, you see they have a lower mean average percentage error and a lower standard deviation, which shows that indeed their proposed approach is improving upon the traditional statistical model. So this is the visualization of their linear regression model. So in terms of limitations, so their model only deals with three regressors, and we know that in machine learning it's the data that makes your model a good model. So three features are quite a small number. So with that, there's still need for a richer and sufficiently curated real-world data set with reasonable features to model this kind of problem. And again, linear regression is just a baseline model. There's still a lot of room for experiments with slightly more advanced models, machine learning approaches to begin with. So in conclusion, their research objective was to develop a model that refined the project cost estimate at completion statistical estimator, which they did successfully. And the linear regression model they developed was subjected to a three-step statistical analysis, which resulted in three features or regressors. So after doing the feature analysis and correlation evaluations, they resulted to only three useful features. And lastly, the research does demonstrate a notable improvement in comparison to the standard forecasting method. Thank you.